This was 10 years after I set my first world record on inline skates. So I'll tell you a little bit about the idea. We have a timeline from the first record. Then I'll tell a bit about the product, and we will end where I'll explain what kind of difference we can do in different applications. So the ceramic balls, it took 20 years of development. I have some balls right here, steel ball and ceramic. We can just pass them on, let them go around. I'll give you the details later about the balls, but they are much lighter. Actually, they're 58% lighter than steel. They will not corrode. They're almost 2.5 times harder. In '97, I participated at the European Championship after I did my first world record on inline skates, 24 hours, 402 kilometers. It was an outdoor course. It was done on steel bearings and in raining condition. But anyway, I had, for my whole career on inline skates, I have always been chasing the small details. And we take a look at the next picture. Yeah, that's me with the yellow helmet. I don't know if it's good enough to see, but we have some friction. The speed is approximately 45 kilometers per hour. The wheels are doing 3,000 RPM. The bearing used on inline skates are the size 608. It can do approximately 45,000 RPM. But next picture here, we have friction with and without load. It means that when the inline skate touches the ground, the bearings are spinning at 3,000 RPM. This one would also be spinning at 3,000 RPM. Maybe only 2,000 because there's so much friction in this one. You would never be able to do 45 an hour. So you want to minimize the friction. I don't know if you can see. But this is what all inline skaters want to have. A bearing that just spins and spins. So that was the idea. Because if you lose RPM when the wheels are airborne, we can say we lose maybe 200 RPM. You have to accelerate the bearings up again. So it's really, really important to have friction without, to decrease friction without load. Also with, of course. So this led me into the next world record, because suddenly I started to get sponsored by SKF after the first world record. SKF is a big Swedish company, plus 40,000 employees, very conservative. So I decided to set a new world record in better conditions in a supermarket. Yeah, I also need some publicity, like the rowers. It's hard to get publicity. Luckily, it was in the late 90s where everybody in Denmark, or I think almost 20% of the population, had inline skates. So I think many of you have some old ones back at home. The crazy thing about the bearings was that the price was 800 Danish kroners, a little more than 100 euro per bearing. I needed 20 bearings. I started to work for SKF in '99. When I got my first bicycle to do some cross-training, I discovered that all the bearings in wheels, bottom bracket, rear derailleur was terrible. And remember, my world was this kind of bearings instead of this. So I started to have a little chat with Bjarne Riis about upgrading the bikes for the team CSC. Now it's Saxo Bank. So we did some tests in already back in 2000, 8 years before the rowing boat knew about the material. And they approved the bearings after a few months. In 2001, the team went to the Tour de France. I was there for 4 weeks, upgrading the bikes and trying to convince other bicycle teams to use the ceramic bearings. But like rowing, most of the teams are really, really conservative. Why change something that aren't destroyed? It's working. Just extra work for the mechanics. Anyway, I think they won 2 stages that year, and Lauren Chalabert, who's on the picture, took the mountain jersey. So it was quite a success. So the vision is to be best in motion. And motion can be forward, it can be standing still, it can be rotating, whatever. And we also want to be part of the victory, like with the rowing boat, like with the Tour de France riders that are winning. So a little bit about the product over here. We have the 58% lighter ball. It's 63% stiffer. It's 70% more temperature stable, which means under heat it will not expand as much, which means that the bearing for inline skating, instead of being capable of doing 45,000 RPM, we can do 65,000 RPM with a hybrid bearing. 128% harder. The surface needs to be 400% smoother. If the surface was the same as on a steel ball, it will start grinding the raceways. Material that is 2.3 times harder needs to be smoother. And then we have the electric isolation also. So I'll make this pretty short, but since we're talking about materials, we'll go to how the balls are made. It starts with the powder, silicon nitrate that are mixed with other acids. We have the milling here, powder treatment. It goes into forming, pressing. And then we have the sintering, hot isostatic pressing. The first 10 hours, the pressure is built up to 1,200 bars of pressure and 1,800 degrees centigrade. Then for 10 hours, the machine keeps this pressure at 1,200 bars. It turns the white ball to this dark one. I don't know, have you seen it all? It has been all the way around? No, not yet. But it's dark gray. For the last 10 hours, the pressure goes off and the temperature reaches the room temperature. Then we have some grinding and lapping. Any guesses how long time does that take? A normal steel ball are finished within 1 day. This process takes 4 weeks non-stop. After that, inspection. Actually, all the balls are inspected by 2 individual persons on the microscope to be sure that the surface is absolutely perfect. You don't want to have... I mean, ceramic can be in a round shape, or it will just splinter, break. A steel ball can be oval. So I don't know what the specification is for the surface structure, but I think it's less than half a micron that you can have a small structure. The complete process takes between 50 and 70 days before you can start to produce bearings. The batch, depending on the size, but one batch can be from 100 balls to 10,000, depending on the size. The balls can be produced from 0.5 millimeter to 65, and the balls going around now are 41, approximately 41. Then we have the assembly, which only takes a few hours. So next picture, how big is a micron? When we assemble bearings, the steps on the balls are 2.5 micron. So we can have more play in the bearing, clearance, or we can have less. It depends all on the application. If it's for high speed, if it's for racing, if it's for the small wheels on the rowing boat, we can have different opportunities. So the first circle you see is paper clips, 0.8. It's approximately 300 times bigger. Or, yeah, this is maybe 3,000 times bigger. Hole in a bottom shirt. Bristol. We have newspaper print, 0.08 millimeter. Human hair, 0.05. Silk thread, 0.06. So 6 micron. So that is 1 micron. You hardly see it when when you are showing it. Anyway, that's just to explain the tolerances we are working with. The hybrid bearings gives lower friction. You have seen that. You can feel it on the bicycle wheel, but it also increases the stiffness. And if you have a stiffer bottom bracket, you will transfer more power to the chain and to the wheel, so it increases the stiffness. It means also fast acceleration, stiffness to weight, a little bit lighter, but that's not the important issue. And it has a longer lifetime. Normally we say between 4 and 8 times. It all depends on the application. We'll come back to that later. So a little grading from the lightweight men, from another guy. I don't know where Thomas is. Are you on the picture? With the white hat? There you are. You're looking younger, but yeah, it's some of the Danes can read it, but it says, thanks a lot for the help with ceramic bearings in our seats. We were absolutely the only team that had that part with the Olympic gold in an even harder peloton than normal. It speaks for itself. Best regards, Eskil. So it's just a fun story. We have only sold for a few other boats, but not in the same class. It will never be a business for us, but it's always fun to be a part of the victory. We can do bearings without corrosion, temperatures up to 350 degrees centigrade, down to -40 to 50. The ceramic balls has a higher resistance against contamination. It uses lower energy. And if you have particles coming into the bearing, that sooner or later it will happen in most applications, it minimizes the damages on the raceways. It actually will polish up the raceways because it's so hard. If we're talking about friction coefficient, steel against steel is 0.8. Ceramic against steel is only 0.2. So in some applications, if it's mountain bike, you have a really rough ride, you have a lot of impacts, you can be certain that you will have contact between balls and raceways. It will seisure the raceways and it will lead to shorter lifetimes, but also more friction. After the first or second saved replacement, the investment has been paid back. That's also our feedback from the customers.